Hello everyone. In this video we are going to discuss one numerical which is of design of mechanical systems. That is of semester 8 in mechanical engineering of Mumbai University, and it is a question paper of December 2019, and the question is asked for 20 marks, and it is based on the design of gearboxes or gearbox, which is of module 6 of syllabus. Now here in this we are going to discuss in detail that how we will go with structural diagram, ray diagram, speed chart, deviation, and number of death. So these things are asked in the university question paper, and it is repeated every semester, every year. So that is why it is much important, and it is always asked for 20 marks only. So we will try to solve one by one. Now if we check with the question is asked in December 2019. Already I told you it is asked for 20 marks, and it describes like this. It is required to design 2x3 multi-speed gearbox for a lathe machine operation with the following specification. Now N minimum it is 120 rpm, N motor it is 1500 rpm, and GP ratio, that stands for geometric progression ratio. So GP stands for geometric progression ratio. In most of the problems you will see GP ratio only, geometric progression, because in most of the applications of gearboxes we use geometric progression ratio to find number of teeth and all. Now next, it has 4 sub questions, and those are: number 1, A part, it describes, write a structural formula and draw structural diagrams, which is asked for 5 marks. Second, B, draw ray diagram and speed chart, that is also asked for 5 marks. Third one, find the number of teeth of each gear, and the last one, draw deviation chart. So we are going to see one by one how we can proceed with this. Now first we will start with write structural formula and draw structural diagrams, that is A. This answer, this solution is already attached in the link, so you can check it, and in this video I'll tell you how we can draw with it. So let us begin. Now in this video we will solve question 2A, that is structural formula and its diagram. Now the first one, we will check it on given data. Now given data shows that it is 2/3 multi-speed. Now this 2/3 indicates its stages. Means what? Total we have 2 number of stages. Next we have N minimum, that is 120 rpm, and N maximum, not N maximum, sorry, it's motor, it is 1500 rpm. So we have 1500 rpm. And next word, it is called as GP ratio, that is geometric progression ratio. So it is geometric progression, which we are going to denote it by phi, and it is equal to 1.41. Now this is the given data, and from this data we are going to check it how many structural formula we can get, and out of that which is the most suitable formula and how we can draw the diagram. So let's begin with it. Now we have already decided or determined that it is 2-stage problem. So it's 2 and 3. What these things are, we will see one by one. Now here how we can denote or how we can write structural formula, that is important. Now the structural formula is given by Z is equal to P into x1 into P in bracket x2, P3 in bracket x3, and so on. Now this is the structural formula. This is the standard method to write down structural formula. Now here, as we are dealing with only 2 stages, so we don't need this x3 value. Our structural formula will be P1 in bracket x1, P2 in bracket x2. Now the thing is, what is meaning of this P1 and P2, X1 and X2? So where this P1 or P2, it stands for speed steps. It is stands for speed steps or pair in any stage. Now we are talking about gear pair in any stage. And next we have X1 and X2. Those are called as characteristics in each stage. Now here P1 P2, it is speed steps, or it is also called as pair in each stage, and X1 and X2, it is characteristics in each stage. Now we haven't written about Z. What is meaning of Z? Now Z is total number of speeds. Here total number of speed steps means what? Through this formula we are going to derive, we can get how many total speeds we are going to get it with gearbox or in gearbox. So we'll see one by one. Now we know we are having P1 and P2 values, but we haven't found yet X1 and X2 values. So that we will see that how we can determine X1 and X2. Now our formula, general formula, it will look like this. That is P1 X1, P2 X2, which we can write it like this. Now here P1 we can write down 2, or P2 we can write down 3. It is like that. But before getting with this, we will check for the combinations, how many combinations we are going to get it. Okay, this is the standard formula, everyone knows it. Now here we know that this P1 and P2 values, those are 2 or 3, or it can be reverse also. Now how many combinations we are going to get it? Now the total number of combinations, how we can found out? Now we know this is two-stage formula. Now total number of combinations for structural formula. So we will write down structural formula. We can write it like this. It is number of stages factorial. Now here we have 2 factorial. Now here we are going to get it two combinations of X1 and X2. Now how we can go with this? Here for getting combinations we will make one table. In that first we will write down about P. Now in P we are having two values, one is 2 and second is 3. Now we can get with another also, that is 3 and 2. We are not changing the values, we are keeping the same, we are just rearranging them. So here we have two combination. For X, how many combinations we can get it? That is 2 combinations. Now that is 2 factorial, which is equal to 2. Now how we can write that? First we will write about X1, then X2, then we will make it reverse, then we will write about X2, then we will write down X1. Now if we'll check it, how we will get 4 combinations, 4 different combinations. Now for that, first we will take 2 and 3, we will get the combination with X1 X2, we will get the another combination with X2 X1. Then after that we will get 3 and 2, and with this we will get X1 X2 combinations, we will get X2 X1 combination. So in this, all these things we will get total 4 SF. We will write down in short, that is SF, structural formula. So 4 structural formulas that we are going to get it. Now how we can proceed with it? Simple. Our formula is Z is equal to P1 X1 and P2 X2. So we will simply write down in terms of numbers. So to avoid confusion, we will write down SF1, SF2 like that. So first we will write down SF1. It is Z is equal to, now we will write down about first for 2 and 3. Now we will write 2, that is P1 value, we will keep the bracket empty. Then we will write down 3 and we will keep the second bracket, that is X2 value is empty. Now for our standard process, we keep X1 is equal to 1. For any standard gearbox, we have value x1 is equal to 1. Now what about x2? Now for x2, we need value of p which is associated with x1. So we need value of p which is associated with x1, that is this one. Now here, as we have already written that x1 should be 1, and for x2 it should be value associated with x1, that is here we have 2. Now the first structural formula that we have got is that 2 in bracket 1 and 3 in bracket 2. Now similarly we will go for SF2. Now for that also we will write Z. Now again in bracket 2. Now here we will write down x2, and in 3 into bracket x1. So 3 in bracket x1. Now we will write down this formula 2. We will keep x2 blank. We will write down 3. First, we will write down x1 as a 1, and for x2 we need a value of p associated with x1. So value of p associated with x1 is 3. So we will write down 3. So this we have dealt with the second formula, second structural formula. Now similarly we will go with SF3. Now SF3 also Z is equal to, now here we have first 3, we will write down x1, then 2 in bracket x2. Now for this 3 in bracket 1, 2 in bracket x2 means what? The value associated with p1, that is 3. So we will make it 3. Now we have got third formula and the last one SF4, that is Z is equal to 3 in bracket x2 and 2 in bracket x1. That we can write it like this: 3, we will keep the bracket empty, 2, value of x1 is 1, and value of x2, it is the value associated with x1, so it is 2. Now with this method we got 4 structural formulas, and we will write it. So 4 structures formulas. Number 1, first one, Z is equal to 2 in bracket 1 and 3 in bracket 2. Second formula, Z is equal to 2 in bracket 3 and 3 in bracket 1. Third formula, Z is equal to 3 in bracket 1 and 2 in bracket 3. And the last one, fourth formula, Z is equal to 3 in bracket 2 and 2 in bracket 1. So these are the 4 formulas that we have got it. Now we have to select which is the best one and which is the most suitable one. So for that we have very simple rule. Now just concentrate on these formulas. We have to consider all this formula in this structure. Z is equal to P1 x1 into P2 x2. Though we have calculated with the various combination, but still now we have to compare all these formulas with this, that is Z is equal to P1 x1 and P2 x2. Now the rule for selecting the best suitable formula is that whatever the values we have, x values, those should be in ascending order. So how it can be ascending order? Well, simply if we'll compare x1, it should be lesser than x2, then x2 should be lesser than x3. It is like this. Now in our case, in this formula, now if we check with this x1 and x2, so here this formula, it is suitable. If we check for second, here x1 is greater than x2, so we don't need this, so this won't work. Third one, here we have 1 and 3, so x1 is lesser than x2, so this will work. And the fourth one, 2 and 1, so here x1 is greater than x2, so this won't work. So we are going to deal with these two formulas, formula number 1 and formula number 3, that is Z is equal to 2 in bracket 1 and 3 in bracket 2. Third formula, Z is equal to 3 in bracket 1 and 2 in bracket 3. So with this method we have selected that which is the most suitable formula with possible combinations. So out of 4 combinations we know that 2 are possible structural formulas that will be easier or that will be most suitable for this gearbox. Now we are going to see how we can get with the structural diagram. Hello everyone. In the last video we have seen that how we can select a structural formula with the condition or with the rule. That rule was the x value should be in ascending order. So actually I have done a small mistake over here. So it should be like this, that x1 should be lesser than x2 and x2 should be lesser than x3. So this is a small modification just in this video. Next, after this we will check it that how we can go with the next procedure, that is structural diagram. So in this video we are going to see that how we can draw a structural diagram. Now we have two formulas, that number one, z is equal to 2 in bracket 1 and 3 in bracket 2, and one more formula that we got it, z is equal to 3 in bracket 1 and 2 in bracket 3. So these are two formulas, and of these two formulas these are the most suitable formulas as per our calculation. So in this formulas how we can draw with the structural diagram. Now for drawing a structural diagram we have to draw few lines. So number one, there are two things that we are going to separate. One is horizontal line and second is vertical line. So for horizontal line, how many horizontal lines we should draw it? So we should draw horizontal line which is equal to 6. Now what is that? Which is equal to z. Z is what? Number of speed steps. So we have already calculated z value, that is p1 into p2, and that is equal to 3 into 2, which is equal to 6. So we have to draw 6 horizontal lines, and for vertical lines we know that it is two-stage gearbox. So there will be one input shaft, one output shaft, and one intermediate shaft. So it is simply, while writing in formula, it should be n plus 1. Now here this n stands for number of stages. So total we have 2 stages and plus 1, which is equal to 3. So while drawing it, we have to draw 6 horizontal lines and 3 vertical lines. So let's move further. Now if we'll go with the first formula, z is equal to 2 in bracket 1, 3 in bracket 2. So we will draw first 6 horizontal lines, 1, 2, 3, 4, 5 and 6. Now 3 vertical lines. So this is 1, this is 2 and this is 3. So total we have drawn 6 horizontal lines and 3 vertical lines. Now in this how we should proceed. Now this first part, 2:1, it denotes stage 1. So this 2:1, 2 in bracket 1, this is the first stage, and this 3 in bracket 2, this deals with the second stage. Now we know we have total 3 shafts, so we will write down shaft number 1, shaft number 2 and shaft number 3. And what about speeds? So speeds, it ranges from here. So first basic is 1, second, third, fourth, fifth, and the last one is 6. So we are going to get the 6 speeds over here, 6 different speeds, and these are 2 stages in it. Now how to draw with the structural formula? Now in this we have to calculate from this one. So what it shows? It shows it that from this first shaft, on the first shaft, we are going to set one point. So we are going to deal with this. So whatever we have value of x, that on first shaft we should have 1 point, and from that 1 point, so this is 1 point on shaft 1, and from that 1 point, next step is there will be 2 lines. So 2 lines we are going to draw it, and those 2 lines should be having gap of, again, the third point 1. So as per this formula, there should be 1 point on shaft 1. So as it is 6 lines, so its midpoint will be somewhere here, that is 3.5. So we will write it as, suppose, 3.5. So this is the first point. Now through this point we are going to draw 2 lines, gap of 1. So here we are going to plot second point, here we are going to plot third point. If we'll join it, so it will be the gap of 1, that is 3 and 4. It is a gap of 1, and it fulfills our all condition that there is point on shaft 1 and 2 lines at the gap of 1. So similarly, if we check for the second stage, it is already mentioned that there should be 2 points, so our answer is right. So there should be 2 points, and on those 2 points, those 2 points are on shaft 2, and from these 2 points, each point, there should be 3 lines at a gap of 2. So first we will concentrate on, suppose, this point, the lower one. So we are going to draw 3 lines from this point at a gap of a 2. So first line, if we'll draw it here, the second line will be somewhere here, and the third line will be somewhere here. So we will join it. So this is done. Similarly, for this point also, it will be this first point, second point, and third point. Just from this diagram, you'll come to know that these are crossing these lines are crossing, but no point is repeated. That on each point we have separate lines, especially on this one. On this we have multiple lines, that is fine, but at the end points we are getting only one speed. So this is related to the first structural formula, and we will go with the second structural formula. The second structural formula is this: Z is equal to 3 in bracket 1 and 2 in bracket 3. So again the same thing, we will draw 6 lines and 3 vertical lines. So this is 1, 2, 3, horizontal line 1, 2, 3, 4, 5 and 6. So in this, again we will start with this. Now this is our shaft 1, this is our shaft 2, and this is our shaft 3. And in this we have the first stage, that is 3 in bracket 1, and second stage 2 in bracket 3. The similar points, we will start with it. The first one, that there will be 1 point on this. So we will write down the speeds also, 1, 2, 3, 4, 5 and 6. Now in this there will be 1 point, so there will be 1 point at the middle, that is at the level of 3.5, and from that 1 point we are going to draw 3 lines. So again, as it is at the midpoint, so draw here, this is our 1 point, and at a distance of 1 again. So at a distance of 1, this and this, here we will get at the midpoint, we will join the line. And from this, the second stage, there will be 3 points on the shaft 2. So there are 3 points on the shaft 2, and from that shaft 2 we are going to draw 2 lines each at a distance of again 3. So from each point we are going to draw 2 lines at a distance of 3. So for this, if we get with the lower point, so for a distance of 3, this is the 1 point and this is the other. So we will join these 2 points. One is finished. Second one, for this point, again here we will be having next point, and then other one will be here. So we can join it. And the last point, this will be 1 line and this will be other point. So if we check it, if we check for the particular points, the distance is 3 here. Similarly we have followed in each and every point. So if we check, compare with the 2 diagrams, you will come to know the method is same. Now how to select the best structural diagram for this, or for best structural formula from these 2? Now there is a very simple thing that we are going to calculate for node. So the next point we are going to see is, that is node. Now we have done with the structural diagrams. Now in the structural diagrams we are going to check it, the node formula, that from that node summation we are going to select that which diagram is the most suitable. Now for that we have to select the lower speeds. So if we'll compare with the diagram 1, so the load speed is somewhere here, 1. After that, its related load speed, it is here. And next one is this. So if we'll add all those things, so first one, it's node summation. So it will be 1 plus 3 plus 3.5. So it is 7.5. Now for the second diagram, if we check it, the node is, this is the first, this is second, and this is third. So the value related to this, it is 1, this is 2.5, and this is 3.5. So we will add those values. So node summation is equal to 1 plus 2.5 plus 3.5. So it is equal to 7. Now we are going to select the addition which is greater. So in the first case we are having 7.5, and in the second case we are having 7. So we are going to select the first diagram. So the first diagram, the best structural formula is Z is equal to 2 in bracket 1 and 3 in bracket 2. So this is the most suitable and best formula for our problem. Before moving to section 3, find number of teeth of each gear, we have to assume few things, and in this we are going to check for spindle speeds. So now for spindle speeds, we know we have already determined speeds. There are 6 speeds. Now we are going to round it off. So we will make one table. Now in that, the first column will be of speeds in RPM. Now second row, it will be calculated RPM, and third one, it will be rounded off. Now we will make one table. Now we know we have total 6 speeds, so it is 1, 2, 3, 4, 5, and 6. So total we have 6 number of speeds. Now we will write one by one and we will round them off. Now here, now first speed, it is N1, that is N2, N3, N4, N5, and N6. Now if we check for the actual values, it is 120. Second value, it is 169. N3 we have calculated 239, and 4 it is 336, and 5 it is 474, and N6 it is 669. Now we are going to round it off. How? Now for 120 we will keep it 120 only. For 169, so we will keep it 170. For 239 we will make it 240. Then for the next 336 it will be 340. For 474 we will keep it 470, and for 669 it will be 670. Now these are new rounded off RPM that we are going to use it for next session, that is for finding number of teeth and deviation chart. How we have done this? Simply, if it is greater than 5, then we have went for the next number, and if it is lesser than 5, then we have kept the same number. So as per that, 120 it is equal to 120, for 169 it is 170, for 239 it is 240, for 336 it is 340, for 474 it is 470, and for 669 it is 670. So in the next video we will start with number of teeth and deviation chart, stage 1, and there is no deviation in stage 2. So there is a deviation in stage 1, and there is no deviation in stage 2. So here now in this we are going to find out the stage 1, so the table above table given, that is of stage 1. Now if we check it, here we have value of 59, here this is value of 59, and here we have 58. So in this we are going to make it 59. We have already done this, so here we are going to get 59 value. As we will get the 59 over here, so there will be changes in case of next table, that is GB and ZB dash also. So from that we have already calculated that ZB dash is equal to 35, and now we will calculate with GB, that is gear ratio. So for calculating GB, how we can proceed with it? So we know that GB is equal to ZB dash upon ZB, which is also equal to NB upon NB dash. Now if we check for Z dash B and ZB, so from that the ZB dash value we have 35, and ZB value it is 24, so its value will be 1.46. so therefore NB upon NB dash, that will be 1.46. so this is the formula that we are going to check it. Now after getting this value 1.46, now deviation speeds we will calculate, theoretical and practical. So for that we are going to make one table, and before that we need speed chart. So I'll draw quickly a speed chart over here. So we have already drawn a speed chart, so it has 4 shafts and 7 speeds. So it is 1, 2, 3, 4, 5, 6, and last one is 7. So from this, now we know this is 120 rpm, this is 170, this is 240, 340, 470, and the last one is 670. Now this is shaft 1, 2, and 3. This is machine shaft, and we will draw diagram, speed chart. Now for that already we have discussed these points, so I'll just quickly draw it. So this is completed. Now we will draw with the table. Now for that we will make one table which will be having similar thing, the 6 speeds. So first one is serial number, what we have it. Second is speed, that is theoretical speed, and next column it will be of practical speeds. So N, it is practical. Now we will again go for 6 speeds. So 1, 2, 3, 4, 5, and the last one is 6. So it is 1, 2, 3, 4, 5, and 6. Now already we have theoretical speeds we have written, that is 120, 170, 240, then 340, then 470, and the last one is 670. Now there is deviation in a particular point only, and that is related to B. So we will focus on only the speeds which are related to B, and from the diagram this is B and this is A. So if we check for B, the speed deviation, it is for these two speeds, number 1 is this and number 2 is this. So there will be deviation for 670 rpm and 470 rpm. So we have to write down the values deviation for this and this. Now other values are completely similar, so that is why we will write it 120 rpm, 170 rpm, 240 rpm, 340 rpm, and we will keep these two things blank, that is 470 and 670. For getting those two values we will write down like this. Now for 470 rpm, now we know we are going to calculate for NB dash, N dash B, that is NB divided by gear ratio, which is equal to 670 divided by 1.46, which we will take 459 rpm. So this is first value what we got it. And for the next one, for 670, now how we can proceed with it? Now for 670 rpm we need a next speed, so we haven't calculated next speed. So first we will calculate for N7. Now as we are going to deal with N6, so we need next value so that we will get the deviation. Now for N7 the formula will be 120 into 5 raised to power 6, which is equal to 945 rpm. Now for 945 rpm, we are going to check, we are going to calculate for n dash b, which is equal to nb upon gb, which is equal to 945 divided by 1.46, which is equal to 647 rpm. Now as the deviation rate is the last speed, that was for 6 and 6, so that is why as the deviation for n6, so that is why we have used additional speed, that is n7. Now finally we got two answers, and those are, number first one, for 470 rpm we got 459. Now if we check it, we are getting deviation that is lesser speed, and for 670 rpm we got 647. So for 670 we got 647. So these are two deviations what we got it. Now after getting the deviations, we will write down the values of it directly, and then we will draw it in a deviation chart. So for speed deviation, we will make one table again. Now for speed deviation, we have one formula that delta percentage is equal to n actual rpm divided minus theoretical rpm divided by theoretical rpm multiplied by 100. So from this formula we can calculate what is the maximum deviation we have it. Now for that, the next process, we are going to make one table. So in that table we will write down first n theoretical, then n actual or practical, and delta n. Now there are 6 speeds, so 1 2 3 4 5, and here we last, that is 6. So in this case, first one is 120 rpm, then 170, then 240, then 340, then 470, and the last one is 670 rpm. So in actual case we have 120, 170, then 240, then 340, then 459, and the last one, it is 647. Now in this case, if we'll check with this, here we have value deviation, that is 0 0 0 0, and here it is minus 2.34, and here it is minus 3.43. Now here we are getting the final deviation values through that formula. So I'll just show you one of it. So delta percentage, how we can calculate: 459 minus 470 divided by 470 into 100. So here for 459 we are going to get minus 2.34 percentage, and similarly for delta percentage of 647 minus 670 divided by 670 into 100, which is equal to delta percentage, that is minus 3.43, that we have already written. Now we got the deviation here. Now the last point is that limits of deviation. So this is the last point of our numerical, that is limits for deviations. Now how to calculate it? For that we have one formula, that is delta n, which is lesser than or equal to plus or minus 10 into phi minus 1 percentage. Now here phi stands for geometric progression ratio, and that is already given, that is 1.41. So if you will calculate this, delta n will range in between 10 into bracket 1.41 minus 1, which is equal to delta n, the percentage, it will be 4.1%, that is plus or minus. Now through these values we are going to draw this deviation on graph. Now how we can go with that? First, draw one vertical line, that will be our y-axis, and somewhere here we will take one reference point, that's 0, and from that we will draw one more horizontal line, and on this we are going to draw with speeds. Now from 0 we will start with it. Now here it is 120, 1 2 3 4 5, and somewhere here it will be 6. Now we will extend that line. So we write down those speeds also. So here it is 120, the next is 170, the third one is 240, fourth one it is 340, fifth one that is 470, and the last one is 670 rpm. Now after getting writing these values, we have to plot. This is -1, this is -2, this is -3, and somewhere here it will be -4. Similarly here it is 1, 2, 3 and 4. So +1, +2, +3 and +4. Now through these things we are going to draw our deviation part. Now we know for this first speed there is no deviation, so this line will be similar. Similarly for 170 there is no deviation, so the line will continue. Similarly for 240 there is no deviation. Now next we have 340 rpm, so there is no deviation, and for 470 rpm we have one deviation value which is equal to 2.34. so that is here we are going to get one deviation line, so that is 2.34, so -2.34 it is. And for 670 if you'll check, that is -3.43. so here somewhere you will get the deviation line. So this chart, it shows you the speed deviation chart. So this is speed deviation chart, which is the last point of our numerical, and here our problem is over, so which is asked for 20 marks. Now in this we have seen structural diagram, ray diagram, speed chart, deviation chart, calculating number of teeth. So here it ends. So if you have any doubt you can write down in comment section. Thank you.